Okay? But that's the reason why catastrophic failures will be detected during inspection. Okay? And that's why catastrophic is good. Okay? The latent that gets outside, and it's the latent that makes it out to that system failure or device failure when it leaves your plant. That's where it becomes really expensive. Story of quality. Everybody heard of the company called Atari? Right? Huh? Everybody, does anybody remember when Atari did a computer? Years ago, okay? True story. Atari's got this computer. This is like September. They're going to introduce it, and engineering goes to marketing and says, we got a problem. We're not sure that, this thing's all that reliable. We didn't build it right. Marketing says, don't worry about it. We don't want to miss the Christmas season. We'll still launch the unit, and anybody that finds something that doesn't work at Christmas, we'll give them a new unit after Christmas. Atari was in the computer business going into Christmas. Atari was out of the computer business by April. We didn't have email, we didn't have blogs, we didn't have Twitters, we didn't have Facebook. We're talking back in the early 80s. 5 months they were in the computer business, they were out of the computer business, and the reason was their reputation from quality from that first launch was 80% of what they shipped was DOA. Out of business. Nobody would buy their product. Who says quality is not important?
Which is more common, catastrophic failure or latent failure?
Probably latent. Okay, but catastrophic is an indication of latent. Mm-hmm. You can have, if you've got a high degree of catastrophic, I guarantee you've got a high degree of reliability problems that are out in the field. From my standpoint, a company should make decisions based upon the quality. And the quality of your work is defined as you build X number of them and you test them. Okay? So what's your quality level there that goes out the door? Because theoretically, 100% of what you ship is good. So you make decisions on quality because that's real time. The reliability of the product, okay, you can't make decisions on that because it's too far out. If it takes 180 days to find out if your product is reliable, then if you make a change, you got to wait another 180 days to find out if it was the right one. You go broke. So you deal with quality. Reliability is a subset of quality. If you've got 10 quality failures, you may get one reliability failure that goes through. So it's a much smaller rate. But it's also 10 times more costly than what happens over here on the quality level. So you deal with quality, and reliability is kind of like the icing on the cake. Because I've never seen quality go up and reliability go down. I've seen quality go down and reliability go out the window. Okay, but as quality gets better, reliability goes along with it. So the catastrophic is more of what will happen. Latent is a little bit of a subsection, but it's so much more expensive. Think of it in terms of like sterilization germs in a hospital. Okay? Everybody gets washed up, everybody gets cleaned up, everybody wears a mask. Okay? You would not want to be in for surgery and have one guy say, I don't feel like washing my hands, I don't like this little mask, or yeah, I got a little flu, but it's not too bad. You don't really want him in there while you're having surgery. Well, the same thing happens with ESD control, is that you want a complete system. The more complete the system is, the better the overall quality control program is going to be, and it's only going to be as good as its weakest link. So, what are the prerequisites for ESD control? Well, first off, we have to identify an ESD protected area, which your company has done. We've got Ben shared, we got ESD areas, we got non-ESD areas. Everybody know where the ESD areas are?
Yeah.
Okay. I just wanted to know. If you don't know where they are, you don't know what to do with them. Okay? The other thing is identify the sensitive items. Now, this becomes real interesting because you've got parts that would be considered not ESD sensitive, electronic component parts, and you've got parts that are considered sensitive. Now, it'd be one thing if your company was building your own product for yourself. And you built the same thing every day, every week, every month, every year. It's always the same. It might be a little bit easier to say, these are ESD items, these are not ESD items, but you don't. What you're building now is different than what you built a month ago. It might be different than what you're working on next week, and so it all tends to turn around and change. Well, you want to learn a new language every week or two? I don't think so. Okay, so it's easier to turn around and say, let's treat all electronic components as sensitive and handle them all the same way. If you handle a non-ESD part, a non-ESD sensitive part, as if it was sensitive to ESD, you will do no harm to the product. But if you make a mistake and you handle an ESD sensitive thing as if it really wasn't, that's not good for the part. So let's always do no harm. Let's always treat it as if it's sensitive item. Okay, and we'll be discussing about what we do with those. So all electronic components, let's think of them as being ESD. Okay? Provide ESD control training. As I mentioned, to me, I think that's one of the most important things. Okay? Giving somebody equipment and not telling them how to properly use the equipment is not the brightest thing in the world. But not everybody turns around and agrees with that. They keep on throwing things at them. But companies that are really concerned about it will invest in training. Here you go. You're invested. Okay, so the basics of ESD control. Well, first off, let's ground all conductors. That's people, that's the device, that's material handling. Now, what does that mean? People. Well, wrist strap, coil cord. Some of us have continuous monitors. Some of us don't. We all do touch testing on our devices and stuff. The grounding of the device, let's assume that this is a ESD item. When I'm working on it, I'm at my bench, I've got an ESD mat. Okay, so the device is grounded by the mat. When I'm done working on it, material handling, metallized bags, put it back inside the metallized bag, close the bag. Let's talk about metallized bags for a moment. Okay? What metallized bags are and what they are not. Metallized bags are designed so that A, you can see what's in the bag, and B, they're what's called static shielding, which means that if you have a large charge on you, okay, because you're in a non-ESD controlled area with this product, that those charges that are on you will also be on the outside of the package, and the package is designed to prevent it from going through the package to the parts that are on the inside. Okay? Therefore, the bag is only good when it is closed. Remember I said the charge was on you, the charge was on the bag. Static is a surface phenomenon. It tends to not go through things unless the path of least resistance is through it. But if the path of least resistance is on the surface, it stays on the surface of things. So if I've got a bag that's open, it's on the outside surface, it's on the inside surface. Okay? And remember we did the little thing where we had this near that? Well, if the bag is open and you're carrying the bag, and of course you're not in an ESD area, but it's inside a static shielding bag, and you've got a charge, and the bag now has a charge, and the inside of the bag now has a charge, now the component has a charge. Now I go up to the ESD area, I turn around, I pull the charge off of the component, off of the bag, you put on your wrist strap, you reach inside the bag, you go to pull out the part, and now you touch a conductive part of the part, and now that conductive part discharges to you, and you don't feel it, but you've just created a problem. So, when you put it inside the bag, close the bag.